Hello everybody, welcome to this episode on statistics. In this video, we will be talking about the margin of error. So there are two scenarios in which you're going to be using the margin of error. Firstly, if you're trying to estimate the population mean, or if you're trying to estimate the population proportion. In this channel, we've talked a lot about the mean, but we've never really discussed the proportion. That's also another thing we're going to be learning in this video. So, margin of error, proportion. What is actually proportion? The proportion refers to the fraction of a sample that exhibits a certain characteristics or has a specific attribute of interest. To understand that more clearly, we're going to be going through an example. So let's say we are trying to find the proportion of students who are using an Apple iPhone in a certain school. So in this scenario, the population is all the people in the school, and the proportion we're trying to find are the people who are using only Apple phones. So we take a certain sample, let's say a sample of 60 people, 60 students, and we ask each of them whether they use an Apple phone or not. Turns out 40 of them use an Apple phone, and the remaining 20 use a Samsung phone. So now we've got the proportion. The number of people who use the Apple phone in this certain school is 40 over 60, so we have to find the percentage. That is 66.6%. So that is the proportion. And that can also be written as 0.66. So that's what we'll be working with. So now how do we find the margin of error of this? This is the proportion, and now we're trying to find the margin of error. We're going to be using this table right here. Let's put this table to the side here. This is the formula we need to be finding the margin of error. I'll explain what the margin of error is in a second. This value over here is called the Z critical value. This key right here represents the proportion we got, which is 0.66, and this N is the sample size. So now let's fill it on in. Now 0.6 is the proportion, 60 is the sample size, and 1 is just it's part of the formula. So now we have to calculate this. That gives us 0.611555539. So what do we do with this table here? This percentage is the level of confidence. We have to choose whether we are going to be very accurate with our information or we're going to be not so accurate. I mean, 80% is still accurate, but not as accurate as the most accurate number here. The most common level of confidence chosen by people is 95%. So that's what we're going to be going with today. But one thing you should remember is that you should always choose the level of confidence at start. That basically means how confident you want to be. So do you want it to be really, really accurate to how the population is like, or do you want it to be not so accurate, but it is still accurate, but not as accurate as 99%. There's some scenarios where you have to be very accurate, and there's some scenarios where you do not need that much of information to prove it wrong. That's where you use this 80% here. So in this case, we're going to be using this 1.96 because that's 95%, because that's one of the most popular choices. So we are going to multiply that with this number here, and that gives us this number right here. And now let's convert that back into percentage. That's 11.99%, also approximately. Now what do we do with this number? What we can say is that we are 95% sure that the number of students using Apple phone in this school is between 54.01% and 77.99%. So what are these numbers? This 54.01 is basically 66%, our proportion we got from earlier, minus 11.99%. And this 77.99% here is basically our proportion plus this 11.99%. So that's what the margin of error is. So we can say that we are 95% sure that it's between here. Now let's find the margin of error of the mean. Most of the steps are the same. It goes like this. First, choose a confidence level. Then take a sample from the population. Then find the sample mean. And lastly, find the margin of error. But this time, the margin of error, the formula for it is a bit different. This is the formula right here. Now, if you recall what I made in the last video about the sampling distribution, you would know that this formula right here, without the z critical value, only this here is the standard error, the formula for the standard error. And one small problem we have for this formula is that we are going to need the population standard deviation. And in most cases, we do not have it. So we have to use a sample standard deviation instead. But it'll be a lot less accurate. So how do we do this? And so let's replace it with a sample standard deviation. The symbol S, that stands for sample standard deviation. So instead of using this here, this table right here, which we talked about in the portion, this table you have to use it only if you have the population standard deviation. So in this case we don't, so we don't use this. We use the T table. If you recall what I taught you guys in the T distribution video, I'm going to put that in the description. The T distribution is mainly used if you do not have the population standard deviation, or if your sample size is below 20. And we are in that situation right now. Our sample size, let's say it's not 20, but let's say it's above 20, but we do not have the population standard deviation. So let's talk, since we already know how to use this table, let's talk about using this table. So obviously this symbol is going to change. Now it's going to be the T critical value. It's not the Z critical value. Now it's the T critical value. Let's just say that this is the sample standard deviation 0.6 and the sample size is 50. It doesn't matter for now. It's just numbers we're just using. So that gives us this here. Just a quick calculation. So what is this now? What is the T critical value? Same thing as before, what we did before. Let's say we choose 95% confidence level, just like we did in the proportion. And now degrees of freedom, that's what DF stands for. We're going to go with 50, because if you saw my T distribution video, the degrees of freedom is basically just the sample size minus 1. So in this case, it's actually 50 minus 1, but it's not that precise. So let's just go with 50 now. And if we intersect both, we would come to 2.009. So if you multiply that, that gives us this. And if we convert that into fraction, that gives us, convert that into percentage, that gives us this. So if we plus minus with the sample mean, this that will be there will be a 95% chance that the sample mean will be that the population mean will be between these two numbers. Okay, that's all I have for this video. So now if we're gonna quickly recap what the margin of error is. The margin of error tells us the range of uncertainty or variability around an estimate or sample statistics, such as the sample mean or sample proportion. I hope you've all learned something from this video. If you have any questions, please leave it down in the comments below. If you want to watch more statistic video like this, check out my playlist. I'll be uploading every week, or subscribe to the channel. Thank you very much for watching. See you all in the next one.